So our next topic is polyalphabetic ciphers. So in contrast to monoalphabetic ciphers, in polyalphabetic ciphers, we have a different character for each occurrence of any given character in the plain text. Say for example, if I have this plain text which is hello. So in monoalphabetic cipher, what did we have? We had same substitution for each occurrence of the same character. So we were having same substitution for all the L's in the given plain text. But in polyalphabetic ciphers, this is not the case. We have a different substitution for each occurrence of the given character in the plain text. So each L which is there in hello will have a different substitution in the cipher text. So that is why we say that the relation between the characters in the plain text and the characters in the cipher text is 1 to many. Okay, so that is the same thing written over here in this point, that each occurrence of a character may have a different substitute, and the relationship between the character in the plain text and the cipher text is 1 to many. So one thing you have to keep in your mind while dealing with polyalphabetic ciphers is to create polyalphabetic ciphers, we need to make each cipher text dependent on both the corresponding plain text character and the position of that character in the message. So say for example, I have this plain text A, B, C and A. So the corresponding cipher text will be dependent on the value of this plain text and the position of the plain text character in the message. So at this position, the value of cipher text for A will be different, and for this position the value of cipher text for A will be different, right? So that is what differentiate or that is what makes polyalphabetic ciphers different than monoalphabetic ciphers. So the key which we use in polyalphabetic ciphers, it should be a stream of subkeys, right? So we will be using a number of subkeys in the given key, in which each subkey depends somehow on the position of the plain text, the thing which we discussed in this point. So each subkey will depend on the position of the plain text character, which uses that subkey for encryption. So this might be somewhat confusing right now, but once we will discuss its types, the polyalphabetic ciphers types, and how do we use it for encryption, and these points will be more clear to you. Okay, so next we will discuss a number of techniques, a number of polyalphabetic cipher techniques, in which the first technique is called auto key cipher. So as the name suggests, see the sub keys in this kind of cipher, they are automatically created using plain text. Now how do we do that? The initial value of key will be given to us, and after that the number of subkeys which we will be using for encrypting, those subkeys will be taken from the plain text. And how do we do that? We create the key just like the way which is written over here, right? So the value of k1 will be given to you, and the next sub key we will use, which will be equal to the value of this p1. Now how do we calculate it? We will do it with the help of an example. The next value of sub key will be equal to p2, right? And this is how we write a cipher text. So this is C1, C2 and C3, right? So in encryption, what we will do, we will be writing, or we will be converting the message into this an encrypted form using this expression, which is we are adding the value of key to the value of plain text and calculating its mode 26. At decrypting end, we will be subtracting that value and finding its mode 26. Now, how we will do this? We will learn it with the help of an example. So here, this is the given example. Now, it says that Alice and Bob agreed to use an auto key cipher with the initial key value, which is 12, right? Now Alice wants to send Bob the message, which is this one. So this is our plain text which says attack is today. So enciphering is done character by character using polyalphabetic cipher, and specifically the auto key cipher using this way. So how we will do it? This is our plain text, right? Attack is today. These are the corresponding values of the characters in the plain text. So these value we can take from that initial table which we also discussed in the previous class, right? So here the value of the value corresponding to A is 0. The value corresponding to T is 19, right? So that is how we write these values. Now, the main thing is the value of key which we will use to encrypt the message. So the given value of K1 is 12. Now we have to find out the subsequent values of subkeys. So that we can, see from here. So the next value of subkey will be P1. So that thing we can check over here. So the value of P1 is 0, 0. So the value of next subkey will be 0, 0, which is the value of P1. The value of next subkey will be the value of P2, which is 19. The value of next subkey will be this one, the value of P3, which is 19, and this process goes on, right? So these values are taken from the values of plain text. Okay, so just like just like these values, we calculate each and every value of key in the for encrypting the message. Now what we will do is we will use this expression and find the value of C. So what we will do, we will add the value of plain text and key, and we will find its mode 26. So 0 plus 12 gives you 12. 12 mode 26 gives you 12. So now to calculate the value of, or to find out the value of the cipher, what we will do, we will check the corresponding entry of 12 in this table. So here you can see this is 12 and its corresponding entry for cipher text is what? This is M. Fine. Next is this 19. So 19 plus 0 gives you 19. 19 mod 26 gives you 19. Then we will check the corresponding value for cipher text in this table, which we get as T. Okay, so we get T over here in the cipher text. So just like this, we will calculate all the values for the cipher text. Right, so this is how we encrypt the message using auto key cipher. Now for decrypting it, we will use this expression. We will be subtracting the value of key from cipher text, and we will be finding out the mode mode using 26. So how can we do this? Say for example, if I take say this example, right? So here the cipher text value is 17, the key value is 14. So 17 minus 14 gives you 3. 3 mod 26 gives you 3 value, right? So here the value corresponding to 3, we check if this is D. So here while decrypting it, you will get a character D over here. So if we calculate corresponding plain text for this value, what we will get? We will get 11 minus 18, which gives you minus 7, and minus 7 mod 26 gives you minus 7, but this is the remainder in minus is not acceptable. So what we will do, we will add 26 to 7. Okay, so minus 26 minus 7 and plus 26 gives you 19. Okay, so corresponding to 19, if we check the value of plain text, what do we get? We get this small t. So here you get a small t in the plain text while decrypting the message. So just like this, we can decrypt the whole message using auto key cipher, right? So this is how we use auto key cipher for encrypting and decrypting the message. Now the next kind of cipher is Playfair cipher. Now this kind of cipher was used by British Army during World War I, and this cipher, it uses this matrix of 5 by 5 size, which has all of the alphabets from A to Z. Okay, and in this matrix there is one entry which is for I and J both. So we can use this entry for both of these characters. Now, how do we create this matrix? We start from this top right corner, right? We will be putting this first alphabet A over here. Then we will drop each and every alphabet diagonally. Okay, how do we do that? We drop A over here, then we will start dropping the characters diagonally. So we will drop B over here, then C. Now this diagonal is completed. Now you will come to this diagonal. So here it is D, E, F. Next diagonal is this one. Fine. So this is G, H, I, J, K. Next diagonal is yes, this one. So L, M, N, O, P. And this is how we complete this matrix up to Z. Now we can use this matrix for different arrangements of the letter, for getting different secret keys by using different arrangement of the letters in the given matrix. So we can use these letters for creating a number of different secret keys. So that is the same thing I was telling you. How do we create this matrix? We create it by dropping the characters diagonally and starting from the top right hand corner. Now the pairs of characters from the plain text are encrypted one by one. So say for example we are given this plain text which is hello. So we will take pairs from it and then we encrypt the pair. So this is one pair, this is another pair, and this is the last character. Now if the two letters in the pair are same, then a bogus letter is inserted to separate them. So here also you can see these two letters are same in a pair, right? So what we will do, we will insert a bogus character in between them. So how we can write it? We can write it as HE, then L. Say for example we have taken letter X. Okay, this will be a pair and this will be the last pair which is LO. Okay, so for this plain text hello, these will be the pairs, right? Now, after inserting the bogus letter, we'll have to check that the number of characters in the plain text is odd or even, right? So if the numbers of characters in the plain text is odd, what we will do? We will add one more extra bogus letter to the end of the plain text, okay, to make it a pair. Say for example, if this would have been plain text of 6 characters, and we have these repeated characters. Say for example, if I add a hello s over here, then यहाँ पे क्या हो जाता, this is one pair he, this is another pair lx, this is another pair lo, this s would have been left alone, right? So we would have inserted another bogus character with this so that we can deal with it as a pair. So this is how we deal with the plain text for encrypting it. Now how that encryption is done, we have these 3 rules for encrypting the given plain text. So we will be using that matrix, this 5 by 5 matrix for encryption. And how do we do this? We will check if the 2 letters in the pair, in the given pair which we have made over here, these pairs, we will see if the 2 letters in the pair are located in the same row of the secret key. Now secret key is what? Secret key is this matrix, right? So if this pair, it has 2 characters, so if both the characters are in the same row, right? So what do we do? So the corresponding encrypted character for each letter is the next letter to the right in the same row, with the wrapping to the beginning of the row if the plain text letter is the last letter in row. Say for example, what does this point say? Say for example, this V and say O. These are the letters in the plain text, right? And we are encrypting them using this Playfair cipher. So what we will do is, why we will see that these both characters are in the same row. So how we will encrypt it? This V will be encrypted to a letter which is next to it in the same row, right? So V will be replaced with which character? S, and O will be replaced with K. So if in place of O it would have been K, then we would have wrapped it, okay, and will move to the first character in the row. So अगर यहाँ पे K होता सेकंड कैरेक्टर पेयर में, तो इसका जो encrypted message है, इसका जो corresponding cipher text है, that would have been X, right? So this is how we encrypt the pairs which are there in the same row. Now the second point says if the 2 letters in the pair are located in the same column of the secret key, then the corresponding encrypted character for each letter is the letter beneath it in the same column. Okay, so how what does this point say? If both the letters in the pair are in the same column, say for example, if we take this column, say first letter is L and another letter is X, right? So इनका corresponding जो cipher text है वो क्या बनता? इसका the letter which is beneath it, which is Q. Okay, so for L we have Q as cipher text and for X we have Z as cipher text. अगर इसी केस में यहाँ पे हमारे पास Z होता पेयर में सेकंड कैरेक्टर, तो इसका corresponding cipher text क्या हो जाता? We would have wrapped it. Okay, so इसका corresponding cipher text क्या बन जाता? L बन जाता, right? So this is what this second point says. Now the third point says if the 2 letters in a pair are not in the same row or column of the secret key. If one letter is in that is somewhere else in the secret key and another letter is somewhere else, they are not in the same row or in the column. So in that case what we would do, the corresponding encrypted character for each letter is the letter that is in its row but in the same column as the other letter. ओके, सो द एनक्रिप्टेड कैरेक्टर, जो भी हम उसको रिप्लेस करते हैं एनक्रिप्टेड कैरेक्टर से, वो हम किससे रिप्लेस करते हैं? फॉर ईच लेटर इज द लेटर दैट इज इन इट्स रो सेम रहेगी बट इन द सेम कॉलम एज द अदर लेटर। सो इस केस में क्या होगा? Say for example, we have these letters as say D and U. Fine. So इसमें क्या होगा? This point says that is in its row but in the same column as the other letter. So यहाँ पे इन दोनों के corresponding D और U के corresponding कौन सा letter हमें मिलेगा? इसका रो और इसका कॉलम. Okay, so L letter we would have been taken for the encryption, right? So we will do it with an example also, so that will make you this Playfair cipher very clear. So next is this example wherein we are encrypting this message hello itself. So what we will do is we will create pair first of all. Okay, so the same pairs will be created H E. Now we will see that two same characters are appearing over here, so we will have to insert a bogus character. So this will be the second pair and this will be the third pair, right? Now the number of characters are even, so no need to insert the bogus character to the end of plain text. Now we will encrypt the message. Now in Playfair cipher, the key will act as the cipher text. Okay, so we are finding out the key using this secret key for these pairs which we have just created. So that value of key will give you the value of cipher text. Okay, so the value of cipher text will be equal to or same as the key in Playfair cipher. Okay, so how do we create it? Now we'll have to see that both the characters in the pair are if they are in same row or in same column or in different rows and columns. So we will accordingly use these rules for encrypting the message. Now we will take this first pair, okay, which is H and E. So we will see H and E. We can see here now they are in the same row. Okay, so when these characters are in same row, what do? We convert or we encrypt the message using the letters which are next to them. Okay, so for H we will use the character which is next to it. For E we will use the character which is next to it. So the keys which we have are, for H we have E which is written over here. For E we have C which is written over here. So this is the key we get. Okay, and as I told you, the value of key and the value of cipher text is same for Playfair cipher. So this will be our encrypted message for this part of the plain text. Now next part is, or next pair is LX. So we will check for both of these characters in the table. So here is L and here is X, right? So when these both the characters from the pair they are in same column, then what do? We use the character for cipher text, the letter which is beneath the given character. Okay, so the letter beneath L is Q, which is written over here, and the letter beneath X is Z, which is written over here. So this is the key value which we again take as the cipher text value. Now next pair is L and O, right? So here you can see that this L and here is O. Now what do we do? For L, what do we do? Yes, we will go to the same row and the column of O, right? We will use the row of the first letter and column of the another letter, for which we are finding the cipher text. So the letter we got here is B for L. Now for O, what we will do? We will go along the row for O and along the column for L, right? So here we get X. So this is the letter which we get as key, and we will take this character as the cipher text as well. Fine. So for this kind of pair, you need to see the row considering the first letter and column considering the second letter. Fine. So here when we were dealing with L, we have checked the row for L and column for O. When we were considering O, then we checked row for O and column for L. Fine. So this is how we deal with this kind of pair. So for hello plain text, the corresponding cipher text we got is ECQZBX. Fine. Now this is the encryption thing. Now when we decrypt the message which was encrypted using Playfair cipher, these things go opposite. Okay, so here when the characters were in the same row, तो हम next character पे move कर रहे थे while encrypting, but while decrypting what we will do, we will move backward, right? तो यहाँ पे जैसे हमने जो next character use किया, जैसे H के लिए हमने E use किया, तो वैसे ही हम लोग अगर H इसमें है plain text के cipher text के अंदर है, तो उसके लिए हम M को use करेंगे, right? So I'll just tell you quickly with the example. Say for this example, यहाँ पे अगर हमें इस value को decrypt करना हो, what we will do, we will take this pair, okay, EC, because the process is same for encryption and decryption. We will take this pair, fine, E and C. This is the pair we have, EC. So we will see if they are in same row or in same column or not at all. So E and C, they are in same row, fine. So what we will do while decrypting it, we will move backward. तो E को कौन सा कैरेक्टर रिप्लेस करेगा? ये वाला कैरेक्टर रिप्लेस करेगा, which is H. This is the corresponding plain text. C को कौन सा कैरेक्टर रिप्लेस करेगा? Which is here, okay, backward. So which is E. Fine. So just like this, we will be decrypting Q and Z. So Q और Z के लिए क्या होगा? You can see over here Q and Z, they are in same column. तो यहाँ पे beneath की बजाय कौन सा letter हम check करेंगे? Which is above the given letter. So यहाँ पे K के above कौन सा है? L. Fine. And Z के above कौन सा है? X. Okay. Next is B and X. So B और X के लिए हम लोग check करेंगे. This is B and this is X. Fine. So what we will do, they are not in the same rows and not in the same column. So first character यानी कि B को जब हम when we will deal with B, how do we decrypt it? We will go along the row for B, which will take you to L, and we will go along the column from X, which will again take you to L. So next character is again L. For X we will check. So X के corresponding the row will take you to this character, and the column corresponding to B will take you to this character, which is O. So this is the message, this is the plain text you get. So in the plain text also what we will do, we added this bogus character, So we will remove this bogus character because these same characters are appearing over here, right? So the steps which we have followed for encrypting the message, we will just reverse those steps for decrypting the message. So this is how we use Playfair Cipher. Next kind of cipher is Vigenère cipher. Now Vigenère cipher, it was designed by Blaise de Vigenère, which was who was a French mathematician, and this kind of cipher, it uses the given key stream in a repetition. Okay, we will again use the given key repeatedly, and this given key, it will be a stream. Okay, it will not be a single value. This value will be greater than or equal to 1 and less than equal to 26. Fine. So this value of key will be like this. It will be from 1 to, you will be having value from k1 to km, and this key will be repeated. Now how do we repeat it? We will we will be understanding it with the help of this example. Okay, so the expression which we use for encrypting and decrypting the message using this Vigenère cipher, these are the expression which we use. There is one more method for implementing Vigenère cipher, which is using Vigenère table. So we will discuss that method also. Fine. So first of all, we will be using these expressions for encrypting and decrypting the message. Then I'll tell you that how do we use that table. Okay, so the given example is you have to encrypt this message. She is listening using this 6-character keyword Pascal. Okay, so what do we do first of all? We will be writing this key corresponding to this plain text repeatedly. Now what does this repeatedly means? We will be writing this key corresponding to the plain text, okay, like this. Now this is only 6-character key, right? So after 6 characters, what we will do? We will again repeat the key for the characters of the plain text. So here Pascal, it finishes over here. So we will again repeat the same key for the given characters of the plain text. So this is the repetition of the key like this. Now again we have some part of the plain text left. So we will again start writing the key. So if it यहाँ पे कोई characters अगर key के बच भी जाते हैं, it is it is completely fine. So जितने character आएंगे key के यहाँ पे, we will write only those. Now what we will do, we will be writing the corresponding value for the plain text, right? And the corresponding value for the key stream. Now for this, what we will use this table, that initial table which we were talking about in the previous lecture. Okay, so we will take these corresponding values from that table. We will write those values, and then what we will do, we will apply this expression by adding this value and this value, and then apply mod 26. So you can calculate from here. 18 plus 15 gives you 33, and 33 mod 26 gives you 7, right? So again we will check the corresponding cipher text value in the table, okay, and corresponding to this 7 value we have the entry for cipher text as capital H, right? Okay, we can check it from this table also. We will not have to move from one slide to another slide then. So here you can see for this plain text character S, we have the corresponding cipher text entry as capital H, right? Now the next value for this key stream is 0, which is for A, as in Pascal. See, this key stream is given over here, 15, 0, 18, 2, 0, 11. right? So we will use this key stream value along with this plain text with the and that expression for finding out the value of cipher text, right? So this is the encryption part. Now for decrypting the message, what we will do, we will simply subtract the value of key and find its mode 26. So here it is. We will subtract the value of key and we'll find the cipher text. So this is a special case of additive cipher. Fine. This is the thing which is represented over here. So Vignere cipher can be seen as combinations of m additive ciphers. Okay, additive ciphers में भी हमने यही वाले expressions use किए थे दोनों, right? So यहाँ पे भी हम लोग क्या कर रहे हैं? We are using the same expressions and the value of key is different for each character of the plain text, right? So that is the difference here. Okay, so here you can see, this Vignere cipher is shown as a combination of m additive cipher. M as in the number of characters in the given key stream. तो यहाँ पे जैसे क्या है m की value is 6 over here. So we are having these 6 additive ciphers. Okay, one for this key P, another for this key A, another for S, then C, then A, and then L. So we are having 6 additive ciphers over here. So here you can see this key A, this key P we are applying on this character of plain text S, I, and N because we are using the key stream repeatedly. Okay, we are using it in repetition. So we'll be using the same key for S, for I, and for N. Okay, so here these three characters are written and their corresponding cipher text is written. Fine, and this is the whole cipher text. Fine, so it tells you that the Vignere cipher is a special case of additive cipher. Now the another method for using this Vignere cipher is to use this 26 by 26 table, which is called a Vignere table, right? So how do we use it? Say for example, we want to see or we want to check for cipher text, for example, say for this value, right? Okay, so what we will do is, now this is the plain text. Okay, now we have to check the value of the given key for this or the character for the given key, because in this table the characters are written over here. A long row we have plain text, okay, and a long column we have the value of key stream or the keys. Fine. So how do we use it? इसके लिए corresponding हमारी key क्या थी? Here I have written this L for small l, right? So here the value of plain text is small l and the value of key is capital L, right? So we will check the table. So this is small l because the plain text was small l and the key was capital L. So we will move along this column until we reach to this entry. Fine. So we move along this small l and capital L and we reach to this entry, which is the entry for cipher text. Okay, so here we can verify it. For small l plain text and capital L key, we are getting this cipher text capital W, right? So this is how we use it for encryption. We'll check it for one more entry. So here it is, E, corresponding key was C, right? This, here it is, from Pascal we have it. So the plain text value is small e and the key value is capital C, right? So we will check the table again. Small e and capital C. Fine. So we will move along this and along this. So the value we get as ciphertext is capital G. So here we can check we are getting capital G. Fine. So this is how we use that table to encrypt the message. Now how do we decrypt it? For decryption, we will be using the value of ciphertext and the key, and in result we will get the value of plain text. Now how do we do that? Say for example, if I take this entry for ciphertext and this entry for key. Now corresponding to 18 I have S, right? So की यहाँ पे क्या हो गई हमारी, अगर हम पास्कल को भी लेके चलते हैं PAS, right? CAL. Fine. So we have ciphertext as L and key as S. Okay. So now we will check the table. Key is S. Okay. And ciphertext was L. So along this, where is L? You can see it is over here. Fine. So along this key, for this particular key and for this ciphertext, we have to check the value of plain text. So you have to move to this column to get the ciphertext, which is T. Okay, so we can check it in the message. For this ciphertext and this key value, the plain text we have is T. Fine. We can again check for one more value over here. Say for example, I take this value T and this corresponding key is 11, which is L. So the ciphertext is T and the key is L. Okay. Now we will check along it. Key was L and the ciphertext was T. Here it is. Now we will move along this column and we get this plain text entry as I. So we can verify it. For this T, we have I as the corresponding plain text. So this is how we use this Vigneer table for encrypting and decrypting the message. Now one important thing, that how do we create this table? So we have small A to Z from here along rows, along columns, and capital A to Z for key value along rows. Fine. And for this entry, which is A and A, we start it from A, okay, and we go from A to Z, right? For this entry B, we start it from B, and then we go to when we go up to Z. Now after Z, we again, because we do not have any character after Z, then we again go to A, right? For this C value of key, we start this table from C and then we go up to Z. Then after Z, we again start from A, okay, and up to the character until this table gets filled. So this is how you can see entry for any of for any of the position of this table. This key value W, we start from W over here, we get it filled up to Z, and then we again start from A. So each and every row and each and every column in this table is filled from A to Z. So that is why this table is a 26 by 26 table. So this is how we use this table for encrypting and decrypting the message. So in the next class, we will be discussing some more techniques for polyalphabetic cipher. Fine.